So we can conclude that the gases having high compressibility compared to liquids and solids because the gaps between the particles decreases from gases to solids. Is it right or wrong? Solids more closer, liquids little closer, and gases very, very far each other. Is it right or wrong, guys? Yes or no? All of you? That is what you have to remember it. So from that we can make activity. From this we can say compressible, highly compressible. I can make a statement. All of you write it. Compressibility decreases from gases to liquids, and liquids to what?
Solids.
Liquids to solids as the gaps between the particles decreases from gases to solids. So I'll say, so compressibility increasing, solids is less than liquids and liquids are less than whom, guys? Gases. Okay,
Gases.
that is what you have to remember. Okay, Mr. Sam, Mr. Lingesh, Nivedan, Sangamitrai.
Sir.
That is what it is.
Yes, sir.
About the third property, highly compressible. Next, fourth property. This is all you people knows. Thermal expansion. So tell me, thermal expansion also we can call it as what?
Cubical expansion.
Cubical expansion. Very, very good. Very good, Agalya. Thermal expansion. So now tell me, they will show maximum thermal expansion or minimal thermal expansion. Everyone? Yes, please. There, the force of attraction is very, very weak. So that they will show continuously strikes the walls of the container.
Sir, more, sir, because kinetic energy is more.
Yes, yes. So because of the less force of attractions, the kinetic energy is extremely more. Okay. Understood? So then it will be highly expansive, highly thermal expansion, cubical expansion. Now Kishore got wonderful doubt. Sir, if you compress the gas completely, what will happen, sir? Kishore, why we should compress the gas means for transportation. Understand, Mr. Kishore? Transportation and usage and all. If the gas is in exactly like same volume, we people cannot store it because we don't have that much big containers. Understand, Mr. Kishore? If you compress them, we can transport it in a like what less volume so that we can carry more gas in a less volume. That is the reason we'll completely compress. Clear? Okay.
Yes, sir.
That is what. Now, thermal expansion. So if you are taking the thermal expansion, means that is what cubical expansion means. If you provide the heat, then what will happen? All of you, the expansion of the gases increases. Is it right or wrong, everybody? Yes, please respond. All of you. Now, if you observe very carefully, for example, sir, how to prove it? Now you can see, I will take 3 balloons. Okay. One balloon is filled with the sand. Another balloon is filled with the liquid water, and another balloon is filled with the gas. Now all 3 are exposed to sunlight. Now tell me, which balloon will blast first? Everybody?
Gas.
Yes, please. This is filled with the gas, liquid, and as well as solid. Which balloon will blast first? Everybody?
Gas.
Gas. Understanding? So that is the reason why you notice it summer season, punctures are more. What is the reason? Your vehicle puncture, bicycle puncture, or scooty puncture, or car puncture. In summer, it is very, very more. Why, guys? What is the reason? In summer,
Because kinetic energy.
not kinetic energy. Summer, what is there? Kinetic energy is there.
Temperature side.
Sun,
High temperature.
yes. Due to sun heat, the gas which is present inside the tire, it will start expanding. Do you understand, everybody? Clear? Understand, Mr. Lingesh? so that the gas wants to come out from the tire. So that is why you can.
Inside pressure increases.
Yes. Understanding? Not pressure increases, Mari. I will explain you. Listen. So for example, why your vehicle is not supposed to park in the sunny. Now, if all of you observe, basically gases is present inside the tube. Now, if you park in the sunlight, you can see that volume of the gases decreases. Is it right or wrong? All of you? The tire.
Yes, sir.
Tire become weaker and it may blast also, because as soon as if you parked in the sunlight, the gas particles which is present inside, they will gain the more kinetic energy and they'll keep on apply the pressure on walls of the tire. Understand, Ra? Sanjay, Lingesh? They will keep on applying the walls of the tire. Basically, if I put a gas in a closed container, always remember entire gas is trying to exert the pressure on the walls of the container, because the particles are very loosely packed. They always pressurized inside. They want to go outside. So they'll be always exerting pressure on walls of the container. Now, again, if the sunlight will hit, understanding? So sunlight will hit. What will happen? The particles more kinetic energy they will gain and they will exert the pressure on more on the walls of the container. Do you all understand, everybody? On the walls of the tire.
Yes, sir.
Yeah. So that is why the tires will blast when we placed it, when we parked it in the sunlight. Or you can see afternoon time, if you are driving very fastly, more faster the tires will puncture or blast. Have you noticed it? What is the reason? Because already you are traveling more faster, so that the inside the tire pressure is more or less. All of you, pressure is very, very high. And as well as you are moving in the tar road. If you are moving in the tar road, tar is very, very heat. Yes or no, guys? Yes, please.
Yes, sir.
Yeah, due to that, particles will get the more kinetic energy. So they will exert the more pressure on the walls of the container, so that the tires will puncture or the tires will blast. Is it okay, guys? Understood? All of you?
Yes, sir.
That is what. So during its burst, what is the reason? The balloon is bursting or tire is bursting, everything. Because of what reason? One of the property of gas. What is the property? Thermal.
Thermal.
That is what. Right. Understand, Nivedan? Kishore? Yeah, right. The
Sir.
gases show high thermal expansion, because what is the reason, everybody? Because of weak something. What is that? Weak intermolecular
Yes.
force. Enna Lingesh? Force of attraction. Understand? Space is null space irukka. Okay, wow. Attraction in gases. Okay, that is what. So these particles will exert pressure on continuously in where? They'll exert the pressure on walls of the container. Clear? That is what you have to remember. The particles of gases continuously strike. Please focus here. Who is that? Mute yourself. Lakshanya, focus on class. Particles of a gases continuously strike on the walls of the container, which causes pressure increases or decreases. Everybody, pressure, which causes pressure on the walls. Okay, so it is a common experience that if you place a air balloon in the air, in the sun, is it will blast or not? Everybody? Yes, please. It will burst. The inflated balloon will burst in the sunlight. Because of what reason, guys? Due to the reason, respond.
Thermal expansion.
That is what you have to remember. Clear, guys? Everybody? Understood?
Yes, sir.
This one. Okay. Next property. Fifth property. That is what we used to call low density. So now tell me, gases, particles, the spaces between them is more or less? The spaces between them is very more. So that what is happening, guys? The particles are very far each other. So the mass per unit volume is less or more? Everybody. Mass per
Less.
unit volume, less or more? Less.
Yes.
Okay, that is
Less.
what. That is what. The density of gases is very low. The density of gases is very low. Open Raj, focus here. The density of gases is very low. Because what is the reason, guys? Because the particles are very far apart or very closer? All of
Very
you.
far apart.
Far apart.
Very far
They are
apart.
very far.
Yeah, the particles are the particles of gases. So Gokul Raj, can you hear me? Gases are very far apart. Okay, so it means that number of particles per unit volume are very less or more?
Yes.
Less. Very less.
Very less. Now Kishore, another doubt came. Sir, if the tire is very thick, is it will block? Is it will block blast? Understand, Kishore? Block, not blast. Of course, it may not blast, but the amount of air in the tire will decreases. Is it okay, Mr. Kishore? Due to the pressure through the wall, that puncture wall or somewhere, it will come out. To the nozzle or somewhere, due to the pressure, it will be coming out. Okay, the tire will become weak. Yeah, not block, blast. Keep it in mind. Or burst, we can say. Burst we can use. That is the correct word. Okay. Sariya Kishore? That is okay. Very apart. So it means that the number of particles per unit volume, they are very less or very more. Everybody. Very less. The number of particles per unit volume. Unit volume are very few. So mass per unit volume is less or more? Everybody. Mass per unit volume.
Less. Less.
Yeah, mass per unit volume. So mass per unit volume we used to call something. What is that called as? All of you.
Density.
Density
Density.
is, yeah, very low. Understand, Agalya, Shivani? So density is equals to, what is the formula? Density is equals
Mass.
to mass by volume. So
volume.
gases are having less mass for more volume or more mass for less volume? Everybody. Less mass for less
More volume.
mass. Less mass for more volume. So that low density or high density? Everybody. Low
Low
density.
density.
Okay. That is
Sir,
what.
can you please a little bit down the screen?
Yeah. That is what. Okay. Understood, everybody? Now, hydrogen balloon or air balloon, which will fly very higher. Anybody can tell me?
Hydrogen, sir.
Hydrogen.
Air balloon. Suppose I will blow the air into the balloon and the one person will fill with the help of cylinder. Now, which balloon will fly very high? Everybody. The balloon
Hydrogen.
filled with air or the balloon filled with the hydrogen? Respond.
Hydrogen, sir.
Hydrogen. Because compared to air density, hydrogen density is less or more? Everybody.
More.
Less.
More. More means it should not fly, Mr. Nivedan. Hydrogen density. Less density only it will fly easily. Yes or no? Understand, Ara?
Yes, sir.
Okay, that is what. Please remember that. So hydrogen density, you know that how much it is. So if you take hydrogen balloon, so which balloon will fly more? You might be check it. Hydrogen balloon or balloon with air balloon. Which one? So if you notice it, air is a mixture of so many gases: nitrogen, hydrogen, oxygen, carbon dioxide, etc. But hydrogen balloon only filled with what? All of you. Only with the hydrogen gas. So its density is 0.08375 kilogram per cubic meter. That is the density of hydrogen. Understand, all of you? Please respond, guys. Yes. But if you take the air density, if you take the air density, almost you can notice it 1.225 kilogram per cubic meter. So which is bigger, air or hydrogen? Everybody, all of you, air or hydrogen? Whose density is more? Air density. So that is why who will fly easily? Hydrogen balloon or air balloon?
Hydrogen.
Hydrogen balloon. Understanding? Because the low density. So the density is low, they can fly in very higher elevations. Is it okay, guys? That is the reason hydrogen gas is very low density, which makes the balloon fly in the air very heights. Is it okay, guys? Understood?
Yes, sir.
Respond. That is what. Next property. Sixth one. Rigidity and fluidity. So rigidity and fluidity. Of course, fluidity means we know that. Yesterday also I taught you. What do you mean by fluidity? Flow. Yes or no?
The flow of
Easily. Now you tell me. They are having rigidity. The particles are very far apart. So that is there any particular shape for them? Shape means rigid, solid structure. They're having it no perfect structure. Is it having a perfect structure? All of you? No. Why? Particles are very far each other. So that is the reason they are having very negligible rigidity, but fluidity, they can move faster or not, more than a gases, more than a liquid.
Yes,
They
sir.
can move far. That is what. Yes or no? All of you respond.
Yes,
That
sir.
is so right. Due to the intermolecular attraction, least or negligible attraction. Intermolecular attraction is least in gases because what is the reason? All of you, because of what is the why intermolecular attraction is very least? Because of what is the reason? I want to know. Because of,
The particles are far apart.
yes, that is what we used to call. What we used to call large intermolecular space. Yes or no, Lingesh? Pranav? Intermolecular spaces. So that is why. So due to this reason, they're having gases have negligible, okay, negligible rigidity and what is that? High fluidity. Is it okay, guys? Understood? All of you?
Yes, sir.
That is what. Now, last property. By this time, you might be guess the last property. Anybody?
Diffusion.
Diffusion. Very good. So diffusion. Now you tell me again, same reason. Because of least force of attraction, maximum kinetic energy, high fluidity, the gases can diffuse very fastly or very slowly. Everybody.
Very fast.
Very fast.
That is what it is. That is why you can see. Understand? If a gas is leaking in our cylinder, even you are very inside in our bedroom also, you will be easily smell it very fastly. Is it right or wrong? All of you. Because of what is the reason? All of you.
Diffusion.
Because of fast rate of diffusion. Write it. In gases, the rate of diffusion is very high, as their particles have high kinetic energy or low kinetic energy.
Low kinetic.
Low.
High
Who is
kinetic.
that low? Nivedan ennara?
Sir, Nivedan said high kinetic energy only, sir.
Who said low kinetic energy? Kinetic energy. Write it. Clear? So the rate of diffusion increases with what? Suppose now again temperature is increasing. So rate of diffusion increases or decreases? Temperature increasing. Yes, Mr. Nivedan. Temperature increases. So kinetic energy increases or decreases? Increases. So temperature increases, rate of diffusion increasing or decreasing? Everybody, Sangamitra, never open the mouth. Huh? The rate of diffusion increases or decreases? Increasing with the temperature. Everybody. Increases with Understanding? Increase in temperature. Increase in temperature because what is the reason? If the temperature increases, something is increasing. What is that, guys?
Kinetic energy increases.
The kinetic energy of particle increases with rise in temperature. So that is what it will be happening. So due to that reason only, you can see the perfumes of your spray, whatever it is, the perfume if you spray, very quickly it will be spread in summer season compared to winters. Is it right or wrong? Why? Winter season it is slow and summer season very high. Everybody, very fastly we can smell it, perfume. I want to know why in winter season perfume smell is slow.
Particles move faster.
Yeah.
Because the kinetic energy.
Yeah, summer season due to the more heat, more kinetic energy, so that the particles will move fastly. Is it right or wrong? All of you.
Yes, sir.
Yes.
So in winter season, the temperature is very low. So particles are having little bit less kinetic energy. So that is what you have to remember. Is it okay, guys? All of you?
Yes, sir.
Yes. Now, from this, observe very carefully solids, liquids, and gases. So, from solids to liquids, diffusion is increasing or decreasing? Solids to liquids, diffusion is increasing or decreasing?
Decreases.
Increases. And liquids to gases, increases or decreases? Liquids to gases, increases. Yes or no?
Increases.
But density, solids to liquids, density decreasing or increasing? Solids to
Decreasing.
liquids, density decreasing. Understanding? And liquids to gases, density is decreasing or increasing? Everybody?
Decreasing.
Decreasing. Mr. Gokul Raj, focus on class, boy. What is this disturbance for me? So that is what. Now you tell me. So density and rate of diffusion, both are inversely proportional to each other or directly proportional to each other? Everybody?
Inversely proportional.
Inversely
Inversely
proportional.
proportional to each other. That is what, write it. Okay? All of you, right? So gases can intermix very easily or very tough to intermix? Gases.
Easy, sir.
Very easily they will intermix because the rate of diffusion is inversely proportional to what?
Density.
Rate of diffusion. Rate of diffusion is inversely related with the density. So who is having high density? Density, all of you. Density, solids greater than liquids greater than gases. Next, rate of
The
diffusion.
rate of diffusion is inversely.
Yeah, inversely related with the density. Rate of diffusion, who is having greater? Gases followed by liquids followed by solids. Is it right or wrong? Both are opposite. Have you checked it, everybody? Shivani, understood? Sangamitra? Yes. So gases having low density, so they diffuse very quickly, and gases having high density diffuses slowly. That is also how to remember. Okay. Now, if I take for example, I will give you hydrogen gas and I will give you carbon dioxide gas. So which gas will diffuse more faster? Hydrogen gas or carbon dioxide gas? All of you. See, I am not comparing solid, liquid, and gases. I am comparing only gases versus gases. Of course, some gases, some gases have low density. Actually, all the gases having what? Low density or high density? Low density.
Low density.
In that also, some gases having little bit more and some gases having little bit less, little bit high density. This is high density gas, this is low density gas. Now tell me which will be diffusing more faster? High density gases or
Hydrogen.
Huh?
Density gases.
High density gases will diffuse more. What is this
Low
nonsense?
hydrogen.
After teaching
Low
everything, you
density
look like that.
gases.
So who will diffuse more faster now? Hydrogen gas diffuses with high speed or carbon dioxide with high speed?
Hydrogen, sir.
Gas. Understand?
Hydrogen.
If I compare gases with the solids and liquids, gases having high diffusion. But among the gases, if I compare, in that also some gas is having low density compared to other gas. That gas will diffuse more. Purima? Yes, that is what. Write it. The gases having low density diffuses quickly Lakshana, you mute amma. Diffuses quickly, and the gases having high density Mr. Sam Purima Sam, high density diffuse slowly. But compared to solids and liquids, all the gases having what? High density, high diffusion or low diffusion? Diffusion rate, high. Understand, Amma? Everybody, please respond.
Yes.
That is what. So,
Sir.
density of hydrogen is less than density of carbon dioxide. So, diffusion of hydrogen gas is more or less. Diffusion of hydrogen is more than diffusion of CO2. Is it okay? Purima, both are inversely proportional to each other. Understand, Mr.? Please respond. Yes. So this is what about all the properties of gases. So we finished all the liquids, solids, and as well as gases. And then tomorrow's class, we people will study next what is the fourth state of matter and as well as fifth state of matter. And of course, one more property of gases is there. So that is what we people will study.
Plasma
Gases
and
exerts pressure. Okay. So gases also can exert pressure. That of course we'll discuss in our tomorrow and class, and we'll continue from there. Okay, with this I'll stop the today's class. I hope you all are very clear. Anybody having any doubt, you can ask me, or else you can leave from the meeting. Is it okay, guys? Understood? Yes?
yes, sir.
Okay.
Yes, sir.
Yes, sir.